Here we're going to solve a system of linear equations using Cramer's rule, this time with 3 variables and 3 equations. Here's our system. We have 4x minus 3y plus 2z equals 15, negative 2x plus y minus 3z equals negative 15, 5x minus 5y plus 2z equals 18. So we have all of our equations in standard form. The first thing that we need to do is find our determinant of the coefficients, d. So we need the determinant of 4, negative 3, 2, negative 2, 1, negative 3, 5, negative 5, and 2. Now we don't have any zeros anywhere in this determinant, so we can expand across the first row. So we'll have 4 times the determinant of 1, negative 3, negative 5, 2, minus negative 3 times the determinant, negative 2, negative 3, 5, and 2, plus 2 times the determinant of negative 2, 1, 5, and negative 5. So we'll get 4 times 2, minus 15. So we'll have negative 3 times negative 5 is positive 15, so we'll just have 2 minus 15. Minus and negative is going to give us plus 3 times negative 2 times 2 is negative 4. Negative 3 times 5 is negative 15, and we're subtracting, so we get plus 15. Plus 2, negative 2 times negative 5 is 10, minus 5 times 1, which is 5. So we'll have 4 times negative 13, plus 3 times 11, plus 2 times 5. 4 times negative 13 is negative 52. 3 times 11 is 33. And 5 times 2 is 10. Negative 52 plus 33 plus 10 will give us negative 9. So our determinant of coefficients d is negative 9. Now we need to find dx. For the dx, to get this determinant, we're going to replace the coefficients on x by the right-hand side, or those constant coefficients. So we'll have 15, negative 15, and 18. Then we keep the other remaining coefficients, so negative 3, 1, negative 5, and 2, negative 3, 2. Again, we have no zeros, so we can go ahead and expand across the first row. So we'll have 15 times the determinant of 1, negative 3, negative 5, 2, minus negative 3 times the determinant, negative 15, negative 3, 18, and 2, plus 2 times the determinant, negative 15, 1, 18, and negative 5. We'll have 15 times 2 minus 15 plus 3 times negative 30 plus 54 plus 2 times negative 15 times 5, negative 5 will give us a positive 75, and minus 18. So here we'll have 15 times negative 13 plus 3 times 24 plus 2 times 75 minus 18, which will be 57. 15 times negative 13 plus 3 times 24 plus 2 times 57. If we evaluate that, will get us negative 9. So dx, the determinant for x, will be negative 9. Next we need to find dy. To find dy, we're going to proceed basically like we did for dx, except we're going to replace the coefficients for y with the coefficients of the right-hand side. So to get dy, we'll have the determinant of 4, negative 2, 5, 15, negative 15, 18, 2, negative 3, 2. Just going to expand across the first row again. So we'll have 4 times the determinant of negative 15, negative 3, 18, and 2, minus 15 times the determinant negative 2, negative 3, 5, and 2, plus 2 times the determinant, negative 2, negative 15, 5, and 18. We'll get 4 times, negative 15 times 2 is negative 30, minus negative 3 times 18 is negative 54, minus 15 times, negative 2 times 2 is negative 4, minus negative 15, plus 2 times negative 36 minus negative 75. So here we'll get 4 times negative 30 minus a negative 54 is going to be positive 24, minus 15 times negative 4 minus negative 15, it's going to be positive 11, plus 2 times negative 36 minus negative 75 is 39. And so if we clean this up, we end up with dy is equal to positive 9. Now we're going to find our last determinant, dz. To find dz, we're going to proceed, as we've done in the past, by replacing the coefficients for z by the coefficients on the right-hand side. So we get the determinant for negative 2, 5, negative 3, 1, negative 5, 15, negative 15, and 18. We'll just expand across the first row again. So we'll get 4 times the determinant of 1, negative 15, negative 5, and 18, minus negative 3 times the determinant of negative 2, negative 15, 5, and 18, plus 15 times the determinant of negative 2, 1, 5, and negative 5. So here we'll have 4 times 18 minus 75, plus 3 times negative 36, plus 75, plus 15 times 10 minus 5. Gives us 4 times, now 18 minus 75, it's going to be negative 57, plus 3 times, negative 36 plus 75 will be 39, and then plus 15 times 5. Evaluate that out, we'll get negative 36. And recall that we had that d was equal to negative 9, dx was equal to negative 9, and dy was equal to positive 9. Now that we have dz, we can actually solve our system. X is equal to dx over d, so we'll get negative 9 divided by negative 9, which is 1. Y is equal to dy over d, which is a positive 9 over negative 9, so we get negative 1. Z is going to be dz over d, which is negative 36 over negative 9, which is 4. So we know x, y, and z, our ordered triple is 1, negative 1, and 4. And again, we need to note that we can use Cramer's rule here because the determinant of the coefficients was not equal to 0. Had it been equal to 0, we would not be able to use Cramer's rule.